Welcome to Practical JavaScript Design Patterns. Now, JavaScript's been around for quite a while, and it's starting to kind of take over everything from the DOM and the front end, and now we've got Node.js on the back end, and with Electron, we've got JavaScript even on desktop applications. And what I want to do with this course is I want to take a deep breath and talk about some practical, real JavaScript design patterns that we can start to use to make our JavaScript a little more readable, a little more maintainable, and give us a vocabulary we can use to communicate with each other as we build out our JavaScript application. So in this course, we're going to talk design patterns. We're going to talk a little bit about who created them, where they came from, and where they originated, what they are, what constitutes a design pattern versus just something that we do. When do we use them? We're going to take a very practical approach. We're going to look at very specific scenarios where we would use design patterns to solve a problem. We're going to talk about where. We'll look at front end, we'll look at back end, we'll look all over the place. We'll do a lot of our work in Node, we'll do some work in Angular, we'll do some just plain vanilla JavaScript. I'll show you where to use certain design patterns. And this is going to be a very practical course. We're specifically implement these solutions in an application so that this isn't just theory, we'll actually have a real world implementation for each of these design patterns. Now, JavaScript's been around for quite a while. It was actually written back in 1995 by Brendan Eich, who was working at Netscape at the time, and he actually wrote it in about 10 days. Now, the JavaScript that you use today and the JavaScript he wrote in 10 days are not exactly the same thing, but the origins of it are the same. And Brendan actually had some interesting things to say about this language that he created and was pretty surprised with how big it became over the course of time. Now, it originally was written to manage the DOM and interact with web pages on the screen, but over time JavaScript has grown up partially due to the rise of these frameworks. So we've got Knockout and Backbone, Ember, React, Angular, and a whole bunch of other ones that are not on the screen. And now with Node.js on the back end and Electron on the desktop, we're starting to have full-blown end-to-end applications that are being written entirely in JavaScript. And because of its origins and the problems he was trying to solve at the time it was created, it's just a little different than a lot of other languages that are out there. And JavaScript is really easy to write really bad code. And I've seen a lot of really good developers move from cool, nice, object-oriented, clean .NET or Java code, and as soon as they start writing JavaScript, it all becomes just procedural, messy, spaghetti code. And so I want to spend some time and fix that for a lot of people. Now, in this course, we're going to start applying more of an object-oriented approach to the way we build JavaScript. A lot of you are coming from either a .NET or a Java background or some other object-oriented language, and objects work a little bit differently in JavaScript. So we're going to work through an object-oriented approach to how we build out JavaScript. And the way we're going to do that is with some tried and tested patterns for clean and elegant implementations. Now, the concept of design patterns comes from an architect named Christopher Alexander. Not this kind of architect, this kind of architect. In 1977, he wrote a book called A Pattern Language, where he began to outline common patterns that he came across while building buildings and towns and cities. And now before you check out and say, I don't build houses, it's not even close to the same thing as what we do in software, listen to this quote from Christopher and tell me if it kind of rings true for us. He said, each pattern that he saw represents our current best guess as to what arrangement of the physical environment will work to solve the problem presented. Now let's change physical to virtual, and this kind of makes sense for us. Each of these design patterns we're going to talk about represents our current best guess as to what arrangement of code will work to solve the problem that we've presented, and we'll do specific problems with specific solutions. And the empirical question centers on the problem. Anytime we're doing design patterns at all, it always starts with a problem. What's the particular problem we're trying to solve, and what design pattern will help us fix that? And the solution, does the arrangement we proposed, does the code we're going to write in fact resolve the problem? And I'll give you some examples of some things that Christopher was dealing with, and then we'll look at some stuff that we deal with in code. So ultimately, it comes down to common problems and common solutions. Now, the problems that Christopher dealt with were around structures and people, and this has been a little while, so I'm going to update some problems that we might face today. And these are things that you would be familiar with. So on and off traffic for highways. So you've got two highways that are intersecting, and you need to go from one highway to the other highway. The pattern that we use for that is the cloverleaf interchange. Right? It's a common pattern that you see almost everywhere, at least in the States, and that's a very common pattern for dealing with that problem. Another problem is pedestrian traffic. So I've got busy roads and in a busy central town area. How do I deal with pedestrians? Well, we have sidewalks. Almost everywhere in the world, there's sidewalks. And that's the pattern that they came up with to solve that problem. And the last one is entry and exit for public buildings. So we want to maintain temperature in the buildings. We don't want the doors opening and closing all the time. So they came up with this thing called revolving doors. And that's the pattern that a lot of buildings now use for dealing with the problem of entry and exit. Now, the theme here is we have a specific problem we're trying to solve and a solution. The design patterns aren't just fun things that we throw in just because, hey, I want to see what happens when I put a sidewalk here. We're trying to solve a specific problem. Enter the gang of four. Enric, Richard, Ralph, and John took Alexander's concepts and turned them into this definitive guide of common patterns for software development. They wrote the book Design Patterns, and really, for all intents and purposes, in the modern day, it's just called the Gang of Four book. And what they did is they provided us with some common reusable patterns for solving common problems that developers face. Again, the focus is on the problem, not on the pattern. Some examples from theirs are things like we want a service layer. I need a service layer that deals with all of my data manipulation. So I want to design a service layer that's going to separate all of my data manipulation code from my controller. So I'm going to use the module pattern. That's what that's all about. The module pattern is going to create a little package that's going to do some work for it. I've got overly complicated object interfaces. So who hasn't seen this? So let's say the DOM, for example. Very overly complicated object interfaces. So we're going to come up with the facade pattern. The facade pattern is just something that's going to sit over top of that complicated object and make things simpler. jQuery is a great example of a facade pattern implemented over top of something that is horribly complicated, like the DOM. The last one's going to be visibility into state changes. So I've got one object that undergoes changes, and I want another object to be able to react when something changes. And there's a pattern for that, the observer pattern. So these are just some specific patterns that we're going to talk about over the course of this course and the problems that they're trying to solve. And for this whole course, we're always going to start with what's the problem we're trying to solve, and then here's the pattern that's going to fix that for us. So what makes a pattern? We've talked about the fact that patterns solve problems, but what's the makeup of a design pattern overall? Well, first of all, it solves a problem. So we've started with that, and that's great. But beyond that, it's a proven concept. Just because something solves a problem doesn't make it a design pattern. It has to be a proven concept that's worked in a lot of different areas and a lot of different applications. And the solution of the problem can't just be obvious, right? I mean, we don't have a semicolon pattern, or we don't have a for loop design pattern. Those are obvious solutions to our problem. These are a little more complicated problems that we're solving, where the solution's not quite so obvious. It describes a relationship 9 times out of 10. So I'm leaving an exception in there, but 9 times out of 10, the design pattern itself deals with a relationship and how things interact in our code. And it has a significant human component. This means we actually have to do something. There's some thought on our side that goes into this to make it really work as a pattern. So why bother with patterns at all? Why do we even care? So the first thing is, why solve a problem again? If this problem has already been solved by somebody, why are we bothering to solve it again when we could just use their solution? A lazy programmer generally tends to be a good programmer because we're not going to go make things complicated. We're going to take something that we know works and we're just going to implement it. It also gives us a common vocabulary, and I think this is probably one of the more important reasons why we're going to do design patterns. Because this way, when we're talking to each other, and software development more and more it's a group collective thing, as we're talking to other developers about what we're doing, this gives us a common vocabulary to use so that we know what we're talking about easily. So let's take a minute and talk about the different types of design patterns that there are and what we're going to look at over the course of this specific course. The first one is creational design patterns, and these are patterns that deal with the creation of new instances of an object. If I want a new object, I'm going to use one of these patterns to create that for me. And the first one is the constructor pattern. And this is one you might be familiar with already if you're a .NET or a Java developer, and this is something that you would use all the time. But in JavaScript, it's a little bit different. So we're going to look at this just a little bit differently and how it works on the JavaScript side. We're going to look at the module pattern. And this is more if I just want a grouping of like methods or a service of some sort. We'll look at the module pattern and how that works for that. And these two are more specific just to JavaScript. You don't see these talked about as patterns in other object-oriented languages. JavaScript has these two specifically, and we'll talk about why that is and what that looks like. The last two on the creational we're going to talk about are the factory pattern and the singleton pattern. And singleton's going to be a little different in JavaScript because you'll find that actually a lot of things are singletons that you might not have realized were singletons. So it's a good idea to understand how the singleton patterns work. The next type of pattern is a structural pattern, where creational patterns deal with creating new objects. The structural patterns deal with the makeup of the actual objects themselves. And we're going to talk about three of these. We're going to talk about the decorator pattern, the facade pattern, and the flyweight pattern. The last one is the behavioral patterns, and these deal more with how objects relate to each other and how they operate, as opposed to the structure or getting a new instance of something. We're going to talk about three. We're going to talk about the command pattern, the mediator pattern, and the observer pattern. And these patterns are ones that are fairly well used in JavaScript. There's a lot more patterns out there. If you read the Gang of Four book or some others, you'll see a lot more patterns than just this. But these are the patterns that are used most often on the JavaScript side. And I'm going to focus just kind of there so that you see only ones that you probably might use in JavaScript. Now, here's how this course is going to work. It's going to be a little different than some other courses I've done. So here's how this is going to work. The first thing we're going to do is we're going to talk about objects in JavaScript. And that might be rudimentary for you if you've been doing JavaScript for a little while. So don't feel like you need to watch Module 2 in this, because I'm just going to talk about how to create objects, what objects look like, and the three different ways to create them. And we're going to talk about dot notation, and we'll talk about bracket notation and object.create and all those things. If you're familiar with all that stuff that I just said, you can probably skip Module 2 and jump straight into Module 3. If you're not familiar with that stuff, go ahead and take a look at Module 2 to get your level set for when we start talking about the patterns. Now I'm going to work through these patterns, and for the most part, the pattern is going to stand on its own. I'm not going to necessarily build one to the next. The first couple are going to set up a theme. We're going to build inside the context of a task object. But for the most part, each pattern is going to stand on its own. So if you only want to learn about the facade pattern, that's fine. Just go watch that series of clips on the facade pattern. But for the most part, you can get away with either picking and choosing or just watching the whole thing. We're going to describe each pattern, and remember that patterns solve a problem. So we're going to talk about the problems that we're trying to solve, and then we're going to solve that problem using the pattern. And so we'll talk about the rules of each pattern before we get going. Then we're going to implement that pattern in Node. And if you don't do Node, that's okay. Go ahead and watch the Node piece, because that's more of just the plain vanilla JavaScript version of that pattern. I'm going to execute it in Node, but if you're doing it inside the browser, it will work the same way. Then we're going to implement it again in Angular, and because Angular is kind of a different beast, and a lot of people are using it right now. So I wanted to take a minute to show you how that would work inside the Angular ecosystem, because it is going to be a little bit different. So that's the way this is going to work for this course. So let's go ahead and get started, and let's talk about some objects.